If you've ever gone to LAX airport and either dropped somebody off or picked somebody up, you know it's shaped like a big oval. And around the outside of the oval are terminals. And the only way to enter LAX is right here, right by Terminal 1. And you enter. And so you got to drive all the way around. If you got to get to Terminal 7, you got to drive all the way around the airport to get yourself to Terminal 7. But what happens if there's a lot of traffic and you got to, say you're picking somebody up and you got to go to Terminal 2. Well, if they're either not ready or then you got to, if you pass Terminal 2, you got to drive around all the way around again and then go back to Terminal 2. They won't let you just sit there and wait. You got to keep the traffic moving. So it's just a steady circle all the way. All right, round again. I mean, I've picked people up and I've driven that circle like 5, 6, 7 times before I could finally pick them up just because it's so crowded and I couldn't get a spot. A coterminal angle on a unit circle is going around and around and around the circle multiple times. So if you go around the circle once, we know how many degrees that is, right? How many? 360. Okay, and if we're measuring in the unit of radian, how many radian is it all the way around once? 2 what? 2 pi. Okay. All right, what do you do if you have to go around the circle multiple times? How do you figure this out? Okay. All right, so before I give you the definition of coterminal angles, I need to practice adding with you. Okay. How do you add these numbers? How were you taught in elementary school to add them? And don't say 2.5. I don't want that as an answer. Okay? How were you taught how to add that? Not a decimal either. We don't do decimals in trig. Okay? Okay, common denominator. Which one has to change? The 2. And what do you change it into? 4 over 2, right? And then you get 5 over 2. Well, the same thing works in pi. Throw a pi on there and it still works the same way. All right, so if you have 2/3 and you need to add 2, you still need a common denominator, right? And the common denominator this time is 6 over 3. Well, why is it 6 over 3 this time and it was 4 over 2 last time? Sometimes little kids have a hard time understanding that. What would you tell them? How would you explain that to them? Okay, well, what is 4 over 2 equal to? What's 6 over 3 equal to? 2. They're both equal to 2, but you choose it based on the common denominator. So then we get 8/3. Right? And if you've got 3/5 and you're subtracting 2, okay, you need a common denominator. And so you're going to change that into 10/5. It's still 2. It's just the common denominator, and you get -7/5. Throw pi on that, and then we're in trig. Okay, you throw pi onto all of these, and now these become trig problems. And so the answer would be 5/2 pi, 8/3 pi, -7/5 pi. Okay, so now let me give you the definition you need today. Coterminal angles. A group of angles only separated by 360 in degrees or 2 pi in radians. Okay, that is the definition of coterminal angles. All right, so let me give you kind of a little silly example. Okay, suppose you have 50 degrees and 410 degrees, and they form a little club, a little group, a little pair. Okay, what's separating 50 and 410? Okay, so they can form a little pair to each other. Okay, up walks a new person, a new angle. Up walks 770. And 770 is like, I want to join, I want to be in your group. And they're like, wait a minute, we have to check you out. We have to see if you can come in. And what do they discover about 770? Why? Doesn't matter if it's over 360, 410's over 360. That doesn't work. What's the separation? Yeah, 770 gets to join the club because 770 is only separated from 410 by 360 degrees. So sure, you can allow 770 into the group. Sorry, 770, my fault. Okay. So then up walks negative 310. Can negative 310 join the group? Okay, why? Okay, well, what's the separation between negative 310 and any one of those other ones? Okay, between negative 310 and 50 is 360 degrees in between them. And so negative 310 gets to join the group. Okay, these are called a coterminal group. How big could this group get? It could get very big. Okay, it could have infinitely many members as long as everyone who joined was separated by 360 from somebody else. Okay, that is called a coterminal group. All right, so here's another example. Who, as in an angle, could join a coterminal group with 100 degrees? All right, well, let's think about who could join that group. So usually I make a list. I start with 100 degrees. And I think, well, the first person that could join that group would be 460, because that is 360 degrees away. And then after that, another one that could join the group might be 820, because it is 360 degrees away. And I could just keep creating group members. Okay, but I could go backwards too. Negative how much? Yeah, negative 260 could join the group as well, because I just subtract 360. And then I could subtract 360 again and get negative 620, and that one couldn't join the group. And this is going to go infinitely on in many directions. It's called a coterminal cluster or a coterminal group. Now the same works in radians. Name 4 coterminal angles to 7/3 pi. Well, this is why we practiced adding 2 and subtracting 2. All right, so we've got 7/3 pi. And we need to add 2 to that. But it would be helpful if we could add 2 with a common denominator. And so instead of just adding 2, what would it be better to think of? 6/3. And so if I add 6/3, I'm going to get 13/3. And then I could add 6/3 again, and that would give me 19/3. And I could keep going, and I could come up with 4 coterminal angles. But let's not leave off the negatives. So we could go back. So what would be the coterminal one that got smaller? 1/3, sure. And what would be a coterminal one smaller than that? Negative how much? 5/3, sure. And you could name it. That's just a sample. Now, why are coterminal angles helpful? All right, here, let me show you why. All right, if you want to find the sine of 11, stick with thirds since we're in thirds. I don't think you have the sine of 11/3 memorized yet. But you can replace 11/3 with a coterminal position, and we want to make it smaller. So let's make that smaller by 2 pi, or 6/3. So I'm going to take 6/3 away, so I get down to 5/3. Hopefully, you do have the answer to sine of 5 pi/3. Okay, that is negative rad 3 over 2. So you're going to take, in all of your examples, you're going to take and either add or subtract a coterminal value. Okay, find the tangent. Okay, so let's find the tangent of 425. Well, it's too big. I want to replace it with a coterminal. Let's do 405. I like that one better. Okay. So I'm going to take 360 away. And when I take 360 away, I'm left with 45. And hopefully, then, you might not have known what the tan of 405 was, but you should certainly know what the tan of 45 degrees is, which is 1. Okay, find the cosine of 27/6. Okay, well that's gigantic. Nobody got time for that, to memorize 27/6. Okay, but we can make it smaller. Okay, so if I'm going to take 2 pi away, what kind of fraction am I looking at if I'm taking working in sixths? 12/6. All right, so take 12/6 away. Taking away 12/6, what does that give me? 15/6. Still too big. Take 12/6 away again. What does that leave me with? 3/6. What's 3/6 actually reducible to? Okay, so this is the cosine of 1/2. And the cosine of 1/2 is the x-coordinate at that position, which you should now be working on memorizing, which is 0. So doing coterminal means you're just working your way either probably through smaller or sometimes bigger. You can do it adding as well. Let's do our last one. Find the cosecant of negative 7/4. Okay, well that's too small. That's a negative number. So we're going to add. And we're going to add 2. And the way we add 2 is by adding 8/4. And when I add 8/4, I get to 1. Whoops, I wrote cosine instead of cosecant. So you take something you don't have memorized and convert it into something you do. And the cosecant of pi/4 is the reciprocal, and so that's 2 over rad 2.